We have some limit problems here that are going to be a little bit awkward. I do want to re-emphasize that anytime we're looking at a limit, our first plan of attack is to try to just simply plug the number in. And in this situation and in this situation, what happens, well, let's do it one at a time. When I plug the 2 in, the top becomes 7 and the bottom becomes 0, which means non-zero number over 0 is going to be some kind of infinity. And we need to figure out which one. So here's where we're going to do a little bit of sign analysis. I'm going to think about approaching 2 from the left. I'll give you a little visual here. So we're talking about the number 2, and I'm just to the left of 2, a little bit less than 2. And we're just going to look at the signs of this expression if that number is slightly less than 2. So if I take a number that's a little bit less than 2 and I add 5, will that be positive or negative? 5 plus something that's slightly more than 2 will definitely be a positive number. If I take a number slightly less than 2 and I subtract 2, would that be positive or negative? If the number is less than 2 and I subtract 2, it'll be negative. So ultimately we'll have positive over negative, which is negative. This will approach negative infinity. I do want to just summarize. There's 2 things that happened that made it negative infinity. The first was that I had a non-zero number over 0. That meant it was some kind of infinity. And then sign analysis told me what kind of infinity it was, positive or negative. So the same process will happen here. My first plan is to plug in a 1. When I plug in the 1, the top is a non-zero number and the bottom is 0. So this is some sort of infinity. In my head, I'm imagining a number slightly more than 1. And I'm going to imagine plugging that in and looking at sign analysis of the top and the bottom, the numerator and the denominator. So this numerator, of course, is always negative. It's negative 3. Nothing you can do about that. And if I have a number slightly more than 1, and I take 1 minus something slightly more than 1, that will be 1 slightly more than 1. That will be negative. That will be a negative answer. And a negative divided by a negative, of course, is positive. So this will equal or approach positive infinity, I guess. I don't know if you're supposed to use an equal sign or not. We're going to. For this guy, this is a totally different example. We have x approaching infinity or negative infinity. So when our x's approach some kind of infinity, we want to think about this as asymptotic behavior. And for these kinds of expressions, we're going back to our pre-calculus work and how to determine the horizontal asymptote. One way to think about this is as x gets really, really, really far from 0, whether it be like a billion or like negative a billion, all that really matters in each of these different expressions is that lead term. So to figure out the limit as x goes to infinity without a calculator, if I haven't memorized all those rules about horizontal asymptotes, is to look at the lead term and the lead term of the numerator and denominator. So this as a single expression is essentially 3x over x squared. And these x's can cancel, so it would simplify to be 3 over x. And as x gets really, really large, 3 over really, really large goes to 0. So this limit is going to equal 0. On the other hand, if I have x go to negative infinity, it's still asymptotic behavior. This is all that really matters, and this is all that really matters. So we'll look at these lead terms as a single expression. This will simplify to x over 4. So now as I think about x going to like negative 100, negative a million, negative a billion, negative a trillion, this is just going to get more and more and more and more negative. It's not going to start to like level off. It's just going to get further and further and further away from 0. And it's going in a negative direction because it's, like I said, negative 10, negative a million, negative a billion. So we know this has no asymptote, and that limit will be negative infinity. Good luck.